Yeah, as you said, Heinrich, I'm really excited to talk about chaos engineering today because there is so much crossover, particularly following after Mark and um, uh, I really enjoyed the way that he was talking about building inclusive practices, because that really feeds into the way that I feel about chaos engineering quite well. Like, chaos engineering really is something that provides us with um, really like an avenue for collaboration and finding insights together and making discoveries. Um, so I think there is a lot of really good crossover with performance engineering. Um, just before we kind of get kicked off, I I couldn't help but run us through kind of like a few of the big nightmares from the last couple of years. So the first one I wanted to bring up was in 2017, the S3 outage. This was massive. It took out organizations like Docker Hub. It affected GitHub, GitLab, Bitbucket, Travis CI, Slack, and PagerDuty. It was so big that AWS couldn't even update their own status page. So the status page said that services were operating normally. Obviously, when you have an outage this big, it's taking down a lot of the development um, uh, assets that we use to ship code and to work every day. So that's really like a massive real world example. And it's not just AWS. We've had other big outages as well. Like Microsoft had a DNS outage that lasted over an hour on May 2nd of 2019. They were looking to migrate legacy systems to Azure. There was an incorrect configuration, and it brought down a huge suite of Microsoft products, and it affected a lot of Azure's products. And it's not just Azure. Like, we have these outages as well that can affect people that don't necessarily work in traditional IT spaces. So another big outage was on January 24th of 2019. They had a second one on January 29th of the same year. So this affected millions of users. Customers couldn't receive email for over 12 hours, and a lot of businesses just shut for the day. Uh, and in case you thought you could get away with it by just not using Microsoft, uh, Apple and Google kind of had the same thing. So Google had an outage that had cascading effects, so big that it affected Nest thermostats. So you can imagine if you've got one of these smart homes, there was actually a period where the climate control was severely affected by an outage in the middle of last year. Uh, which I guess in America, if you're in a hot location, that might be a big problem. Um, uh, I, me coming from the southern hemisphere, that would be a massive issue in the middle of winter, particularly in my parents' place because it was incredibly cold. Um, so that would be a big problem. Um, and this affected iCloud, YouTube, and Snapchat. Essentially, as well, this was another um, uh, example of where a situation where millions of users were affected, and we're really talking about internet level scale at that point. So, what do we take away from this? Failure is everywhere. It's inevitable. It's inherent, particularly in the complex systems we work with. Um, and it'll eventually cause downtime, particularly if it hasn't been tested for. So what do we mean by complex systems? In that respect, we mean a system that is composed of many components that may interact with each other. Just by way of brief introduction, uh, as we've mentioned, my name is Patrick Higgins. My title is a chaos engineer at Gremlin. You can tweet at me at HiggyCodes, github.com at HiggyCodes as well. I'm Australian, grew up in Sydney, now based in Washington, DC. And I've been at Gremlin since it was pretty small. It's been a pretty fun place to be. When I started, we're just kind of coding away in our living rooms, and now it's kind of turned into a pretty cool business to work for. Um, So, by way of an agenda for today, what I'd like to address is why should we do chaos engineering, what it is, and what are some of the things, the principles that we can take away to do these things successfully. And I want to kind of set some like base level principles here. So, historically we've gone from a situation where previously a lot of companies were working in an on-prem environment. We've moved to the cloud, and this has come with some considerable uh, complications. So the good aspects of it have been that it's decreased costs. It abstracts away maintenance some of the time, and it gives us an excellent ability to scale. The bad aspect of that is that the abstraction leads to less control as well. So we've had to think of new ways to build apps. We've moved from monoliths to microservices. And this has really allowed us to increase developer velocity and given us better abilities to scale. So what has this meant? It's meant that it's increased complexity. We've gone from tens to hundreds to thousands of microservices. And this has created these large, more distributed systems with more complexity. The result is that we've had to think of new ways to test and handle failure. As you can see from this image, we've got essentially the balls of death for Amazon and Netflix. These are a couple of years old at this point. So when we're thinking about, trying to create some kind of mental model for applications, you look at these and it can really bring up some real nihilism, and it can be really hard to think of where to begin. And chaos engineering can really be quite useful in this particular context. So at Gremlin, we kind of think about cost of downtime a lot. It can be a pretty big motivating factor for customers that are coming to us. And we kind of break it down into three separate sections. So the first one would be thinking about the first or the most obvious outcomes of an outage, which would just be revenue lost. Particularly working with e-commerce companies, this can be very easy for them to come up with a specific figure for it. And a second kind of obvious metric would be employee productivity. So if employees are spending time fighting fires, that means that they're spending less time working on productive activities that can reduce potential outages in the future. After the outage, we also have the potential for customer chargebacks. So particularly if you work in a highly regulated industry, or you're in the business of having SLAs with your customers, that can be a specific, very quantifiable metric for you. But you also have the ability to think about unquantifiable things as well. They may not come up straight away, they may not be budgeted in, but they do still exist. And those things could include brand defamation. So thinking about, this is obviously something that performance engineers think about a lot when they're thinking about user level metrics concerning sentiment. And then obviously as well, we have the unquantifiable metric of employee attrition as well. So thinking about, particularly if you have SREs at your company that continually have to wake up at 3 a.m., they're getting paged all the time. Eventually, at some point, they're probably going to want to think about getting a job where they, get to work between 9 and 5 and have less of these after-hour incidents, because they're never fun for anyone, and it's a terrible way to work. One of the kind of vicious cyclical patterns that can be generated out of that employee attrition are that if you start having employees leave, that really puts the onus on the employees that stay. So you can find that can be a little bit of a compound effect as well, which is something that obviously all of us really want to avoid. So in terms of what this has in terms of a metric effect on businesses, Amazon has estimated that they lose $13.22 million per hour, or $220,000 a minute. The average for a company working in the e-commerce sector is $300,000 an hour. So you can see that as you start to think about companies that are working at larger scales, obviously the numbers get bigger. But for any companies working, particularly in the e-commerce space, it can be pretty easy for you to come up with some metrics that would be related to your specific downtime and how that would work for your company. So obviously failure can be inherent, and this can cost us tons of money. So what can we do about it? There's plenty we can do about it. And I'd like to humbly suggest that chaos engineering could provide you some benefits in thinking about how to avoid downtime and how to create better systems with and essentially better teams as well. So essentially, it can help you to identify weaknesses in your systems so that you can build ones that are more resilient. You can be trained to identify incidents somewhat more ahead of time. And it can train your team to respond to incidents as well. So it can be looped into things like fire drills, where essentially you create mock incidents ahead of time. There's plenty of examples of SREs just being given a page in their first couple of weeks at a company, really having no solid idea of what that was going to involve for their new job. And having these kind of like proactive fire drill episodes ahead of time can really give new employees some wet feet as they're coming into new roles, and really help to increase that knowledge share and collaboration. So I could not get through this talk without bringing up Ian Malcolm. Like, it was impossible for me to think about talking about chaos without talking about the absolute, prince of chaos. So I just wanted to add in just a few quotations from Ian Malcolm on chaos when he's talking to, I forget the character's name, Laura Dern, the brilliant Laura Dern in Jurassic Park. The first pearl of wisdom he had was that Tyrannosaur doesn't obey any set pattern or park rules. It's the essence of chaos. I didn't think that was really relevant to my talk, but I thought it was just pure gold, so I just kept it in. And the second one that I thought was actually quite useful is that Laura Dern asks him, what is chaos, and I think it was, what is chaos, or what is the principle of chaos? And Dr. Ian Malcolm replies that it simply deals with unpredictability of a complex system, which is pretty close to what we're talking about today. So I want to get a bit into what chaos engineering is. And it is a bit of a misnomer. I think there's a big kind of sentiment in, or something that I think is, thought of a lot as, it's got a reputation of being something where it's really just about breaking stuff and being quite reckless. And it's not. That's not really helpful, and it's not going to make you a lot of friends as well. It's really more about thinking about how to simulate the chaos of a real world in a controlled environment. But essentially, like the thing that we're actually looking to do out of all this is to discover the chaos that is inherent in our complex system to begin with. And I think that is really where performance engineering and chaos engineering kind of mesh together quite well. Is in both instances, we're really talking about observability and discovery. In the instance of chaos engineering, what we tend to be is really focused on the what if concerning what happens when our system is not is in some kind of state that is somewhat unexpected. It is somewhat of an edge case. It's not working effectively in those specific instances. How does our complex system react, and how do we, as part of the complex system, being that systems are social and technical, how do we react as well, and how do we address those concerns? So chaos engineering is, in fact, instead carefully applying failures with an explicit hypothesis. So thinking about things really with a methodological I don't I've lost my words. With a scientific approach. It's methodical, that's what it is. It is methodical. We start with a hypothesis, and what we do is we experiment to validate that specific hypothesis. You're going to have to bear with me. We had our conference here today as well, and it's a little late in the night on the East Coast, but we'll be fine. We'll make it through. So it's about starting small and growing a blast radius as we continue. So essentially what we're looking to do is start with introducing some kind of experiment or change in our system that will be very small scale to begin with, the smallest thing that will essentially yield a signal. And what we want to do is move from that small scale to larger scale tests as we go. We also have the opportunity to move from one environment to another as we go as well. It's about communication as well. It's really about collaboration, much like Mark was talking about before. Communication is incredibly important. If you have plans to run any experiments, it's really important that those plans are communicated with stakeholders. It's also really important after you have any kind of experimentation that you share what you learn as well. Findings from chaos experimentation should be public, and it's all about learning. So essentially what you want to do is share as much as you can to a broad set of people as well. And this really makes everyone better engineers. You know, these people may be working on applications, they may be SREs, they may be performance engineers, they may be in QA. In all cases, you'll find that this kind of collaboration and these opportunities to learn together are really useful for everyone. And you can also share these things internally and externally. There's kind of a burgeoning chaos engineering community at the moment. Lots of people are really interested in the discipline, and it's one worth digging into. A lot of people are finding really interesting problems and experiences at their own companies, and are sharing those kind of experiences quite broadly. So chaos engineering is also about iteration as well. Essentially, much like a gym membership or learning a musical instrument, it's all about you can't just like lift really heavy weights once at one time and call yourself a bodybuilder, or even play a musical instrument for 26 hours straight and become an excellent musician. It's really about generating a practice over time and having an iterative practice where it becomes really just a part of your day-to-day as well. So chaos engineering, to sum it up, is thoughtful planned experiments designed to reveal weaknesses in our systems. And as I said previously, those systems are both technical and they're human. So what we're looking to do is find where our tech is somewhat broken, somewhat insufficient. We're looking to examine what happens if we have some kind of degraded performance, looking at the UX concerning that. And we also want to test things like monitoring and alerting. So we want to know if these things are actually working correctly. Obviously, it's useless if you have them, they're not configured correctly, if you're not getting paged when you should be. All those things should be validated ahead of time. And you also want to think about things that a little more technical, like what happens, is your auto scaling working effectively? Do your retries work? Um, what are your timeouts like? All these very basic concerns really do need to be validated ahead of time and in a proactive manner. And then asking the question as well regarding human systems. So, what does your alert rotation look like? If you have documentation and playbooks for particular outage concerns, what do they look like? Is this knowledge shared? Is it accessible? Is it easy to access? And then if you have escalation processes, what do they look like as well? And when we're thinking about these kind of social and collaborative aspects um, of our everyday, of dealing with working in a complex environment, one way to think about them and one way to deal with them effectively is to think about game days. So um, I think game days are really useful when we're thinking about taking a holistic perspective to our work and creating an inclusive environment, as Mark mentioned previously, because what they do is they provide us with dedicated time as an organization to come together and gain insights together. So really it's about collaborating together. If you bring people from a diverse background, be it, potentially including people in the room from the business side, including people in the room who are working on the applications, who are SREs, who come from a really diverse array of backgrounds, they're going to bring different insights to game days as well. So if you're running chaos engineering experiments together, what it's doing is it's providing you an environment as a collaborative group to prove or disprove particular hypotheses. And to take this to an extreme, it could be really good to include product managers or even designers into situations like this. If you're thinking about UX, and particularly UX for a degraded experience, these are the kind of things that can be proactively built into and coded into your applications ahead of time. If it's just, like classically speaking, chaos engineering seems to be the realm of the SREs. If it's just our SREs that are dealing with these problems, there's no way that that's going to feed back into application design and the way that the products are built. So really building a collaborative environment for this to take place can be super useful to your business and also to your customers. So chaos engineering has just kind of popped up recently as something that has kind of picked up a bit of steam, but it's been something that has been around for quite a while. Before 2010, there's classic stories of Jesse Robin manually wreaking havoc in data centers at AWS by pulling cords out of the wall. That might not necessarily be the scientific lightweight approach that we would really advocate for today, but it does reflect a certain sentiment of asking the question of what happens if this thing doesn't work. After that, Netflix kind of developed the Simian Army collection of attacks in 2010 as they kind of made that way into having a pretty complex cloud infrastructure system. And in 2014, Bruce Wong coined the term chaos engineer, apparently working at Netflix. And there was kind of this move essentially in around 2014 from thinking about dealing with things from a DR, like a disaster recovery standpoint, to thinking proactively about essentially what would go wrong. And then in 2016, Gremlin popped up. The founders were Colton Andrus, who wrote Fit at Netflix before that, and Matthew Fornaciari, who was working at Salesforce, and they both met at Amazon together. So there was definitely some Amazon kind of uh, roots for a lot of the stuff going on, Amazon and Netflix. So we often get asked the question, when's the best time to get involved in chaos engineering? Um, and and the response essentially is that um, the best time was yesterday, the second best time is today. It's like um, systems become increasingly complex, and uh, they're quite dynamic as well. Um, so gaining insights into your system is something that really you want to do as immediately as possible. Um, this is obviously, as I've described, a very proactive practice, and engaging with starting the practice should also be proactive. So I want to just like give a few tips on how to chaos engineer successfully. What are the things that we can do to make sure that we're kind of going in with eyes wide open? The first thing is to think about the vectors for uh, the experiments that you're running. And the way that we tend to break this down is the scope of the attack. So like how many targets are we looking at um, experimenting on? Like how many nodes um, or pods or whatever it may be are you looking to run experiments on? And then the second question is, what is the magnitude of the experiment that you're running as well? So that might be, um, what is the additional CPU load that I'm going to add to specific containers, or like what amount of latency am I going to add to these specific network calls? Any kind of questions like that are considered the magnitude, and it's really important to think about these two vectors um, as kind of like cornerstones for the way that you're looking to target. As I previously mentioned, a second really important thing would be to start small and increase the blast radius. So really what you want to be doing is just looking for a signal initially. This should be something that is done alongside your monitoring tooling. If you don't have monitoring set up correctly, or if you don't have monitoring set up, you should definitely do that first. This isn't a practice we should be doing flying blind. So that would be super important. We want to be doing it potentially on a single host or some kind of single application. Don't do it on the whole fleet. Do it in a controlled environment. Make sure you've got a team ready, and then expand. If you really don't think through creating a safe, prepared, controlled environment before this, you might find your coworkers and your bosses might not be too happy with you taking a cavalier approach to what you might describe as breaking things on purpose. So it's pretty important that you make sure that you have people on your side. This has been explained, the practice has been explained, and that you are really bringing it into your practice as something that is there to improve the pedagogical kind of I guess like the learning culture within your organization. And another vector to think about is how to progress through different environments. So it can be very useful to start in a development or staging environment before you move through to production. This really helps you build up confidence as well. You can start small in a staging environment and then expand your blast radius as you go. And then when you finally move to production, make sure you start with those small vectors again and increase those over time. Obviously, this is really similar to thinking about code changes as well. And you want to really work iteratively. This is something that I think like everyone in our industry can really relate to, um, and whether it be a code change or thinking about uh, performing some kind of experiment. In both cases, really, if you're doing them iteratively, if they're smaller, if they're more often, in both cases, you're going to be in better shape. We get asked the question a lot, what, like, do we have to even do it in production? Can we just kind of like do it in staging environments? And the answer is, I mean, you can get insights into how things are going if you just look at things in staging, but production is where your users are. If you don't have production, testing, recovery won't work when called upon. Um, these environments will never be exactly the same. Like particularly within the performance engineering space, I think people are very aware of that. Um, and regardless of how similar they are, you're going to find that there are differences. So with that being the case, it does make sense to eventually get to the point where you're testing in production with a practice of chaos engineering. It's really just about how do you get there, and thinking about that as kind of like a goal, something to achieve, and something that the organization will be proud of when it happens. And so when we're thinking about chaos engineering, I haven't really addressed what are the kind of chaos engineering experiments we could have. So you could be thinking about things like resource failure. So that might be increased CPU. We could be thinking about, looking at what happens with any kind of disk thrash, issues with memory, I/O, really asking the questions, things like, does autoscaling work correctly? Obviously, particularly looking at the resource failure attack types, like these are questions that performance engineers are going to be asking all the time. We can also think about service failures. So what happens if processes get killed? What happens if there's some kind of like host, pod, or container shutdown? Similar to the classic chaos monkey example. We would kind of recommend that with chaos engineering, you should be thinking about these shutdowns as things that you do assertively and not just shutting down random stuff. But shutdown is very useful nonetheless. And also clock skew, like clock skewing is really can be really interesting. Like looking at what that does to when you're thinking about cert expiry or like potentially like problems with daylight savings times, could be anything. Depending on what your business interests are, some of those things may be important to you. And then we can think about dependency failure as well. So things like what happens if we kind of black hole a specific pod or a specific container, or maybe even a region. What do we do then? What if a dependency is unavailable? What if the network goes bad? DNS is like a really common issue. So what can we do in that particular regard? That so many outages are caused by problems with DNS config. And then also thinking about latency and packet loss as well. And then application failure, like kind of like digging into not just infrastructure, but what are the application concerns? Like that might be something to do with thinking about memory. We could be thinking about what happens with like if we inject latency or throw some kind of errors in our application, what's going to happen upstream and downstream in that particular situation. If we looking to inject failure into our applications, does our monitoring pick that up effectively? Is it being picked up in our logging as well? How is that affecting our timeouts and retries as well? So lots of different really pertinent questions that can be super useful to ask. And then at the end of all that, I think the question is, how can we go from thinking about that as kind of like a one-off experiment to thinking about continuous chaos as well. So how can we think about preventing regressions into failure as we keep going on? These complex systems are essentially completely dynamic. We have code changes all the time. We potentially have new hires, people who leave. The way that our complex systems interacting with those changes is ever present, and really the only way to mitigate that is to be continually thinking about how we can prevent regression. So when we're thinking about trying to prevent regression, there can be a couple of tools in the tool chain that can be quite useful. The first one to bring up is status checks. So if you're having experimentation that you're doing in an automated fashion, it's really important to know when things aren't going within the bounds of what's expected or what's appropriate, and having some kind of stop mechanism for any kind of experimentation that's going on. Particularly if we move into automation, we can't take our hands off the wheel, for lack of a better term, without having some kind of way to remediate. We can also potentially schedule experiments. Obviously, with this one, you probably want to schedule between 9 to 5 as you're getting started. Otherwise you're really not going to make any friends in your workplace. Outside of that, API calls as well, SDK implementations. There's a lot of really good chaos engineering solutions that are out and around at this point, and the community around it is pretty energetic and active, and are really asking questions on how we can create better chaos engineering tooling for a broad community that is, really enthusiastic about it. And then as well, we can think about including chaos engineering into CI/CD pipelines as well. So really thinking about regressions in an environment where we're looking to promote new code. This is obviously something where the crossover to performance engineering is pretty stark as well. And in both, looking at performance engineering and chaos engineering, we don't want to be making changes that are going to create, detrimental effects to the user experience that are going to really affect the business interests of the company. So creating automated methods for avoiding that, it can be really, really useful. So reasons to automate, obviously the one I've been harping on is preventing regression. It also prevents human error, particularly when we're looking at experimentation. We don't want to accidentally implement some kind of experiment that takes down a region or something with a slip of a finger or something like that. I haven't actually seen it happen yet, but obviously we want to be really careful with experimentation happening. We also want to reduce the time spent manually running tests. Really, a lot of this is about lowering that bar to entry and reduce the toil that is faced as well. So I just wanted to quickly, we've got kind of 15 minutes left, but that should include some Q&A as well. I wanted to quickly kind of go through a Hello World demo. It's pretty quick and dirty, for lack of a better term. But I did want to give some kind of like examination of the thing that I've been talking about in conceptual terms for the last little while. So what I put together was just a bit of a demo using Neotys for some load testing, some monitoring with Datadog, and some chaos engineering from Gremlin. And I wanted to apply it to this microservices demo application that I've been toying around with. And Uh, and this is all open source as well. This microservices demo application, we actually use it at Gremlin pretty regularly. And I'm just gonna try to pull this up. Just bear with me. But I'm gonna switch to. I did this ahead of time um, because I didn't want to have any chaos with my presentation. So this is the microservices. Oh, let me just pull this up real quick. Present again. So looking at this demo application, I just wanted to go through thinking about critical and non-critical services for the application itself. Um, so, looking at this application, we kind of assume that things like the ad service would not be in the critical path. That would be an assumption that I'd have about the application. I would assume that if ads were to fail, it shouldn't affect the critical path of the customer checking out as well. And then potentially things like recommendations would be something that really wouldn't be, it wouldn't affect the critical path for the application either. I'd expect it to, Netflix has a really good thing where if your personalized suggestions for videos don't, if that service isn't functioning correctly, it'll just fall back to generics. And I would kind of expect the same kind of thing from this e-commerce site that I'm working on. So I'll switch across to just playing around with the site itself. So this is it here. And what I'm going to do is just like check out. There's the recommendations there. Add some stuff to cart. And you can see I've got some products there. And I wanted to touch the currency as well. Cool. So this is essentially following a pretty similar flow to the user path that I set up in Neoload as well. And then I've just got this. I've essentially got some metrics set up that are tracking just the different services. So that was just kind of like walking through the shop itself. And I'll just switch into validating the first service. So I just wanted to go through validating working with the ad service. So I've got some load going on and add stuff to the cart. That's cool. That's all working quite well. And you can see this ad down the bottom here, right? This is the ad service that we're working with. What I'm going to do is just set up a new attack and go to containers. I'm going to target just the ad service container itself. So this is set up with two nodes there. It's a kind of a pretty small application, and it's hosted on DigitalOcean as well. So I'm going to go to run the attack, unleash that gremlin. Going to wait for that to impact. It'll just take a second to go. You can see it's just affecting that one container, that ad service. So my expectation is, my hypothesis is that this will just affect that service and it won't affect the critical path of me checking out. And that users will be able to use the site as per usual, so it won't affect too much. Okay, so the site looks like it's loading fine. Okay, but the ads are gone. And we can see there's just a red line there for where the attack kicked off. And I'm going to have a look at the TCP response time as well. So I think the ad service has been relatively affected there. I should have checked the response time before I started off with that. Obviously, a quick and dirty demonstration here, but you can see that there's increased latency compared to the other services that we're working with there. And the attack is finished. So the second question I'm asking myself is, how long is it going to take to spin back up as well, to come back online? Still taking a second. So probably at like 15 seconds at this point. Still down. And we're back up. So it took a pretty considerable amount of time to come back up after launching this black hole attack. And you can see there the second red line, which is kind of signifying the end of the attack there. Cool. So that seemed to go as well as I expected, but I think I was expecting that it would take less time to come back up online. So that was probably the interesting takeaway from that, and worth looking into a little bit more. So after that, I just wanted to do one more experiment, just a small one on a different service. So this time I wanted to hit the recommendation service. And I'm going to use a black hole attack as well for this one. And the recommendations would just be the other products you might like there. Cool. So let's unleash that gremlin. My abort conditions for this specific attack would be that the user is not able to check out products, and if that critical path is interrupted, then I would want to halt this particular attack as well. And my hypothesis will be that this should just kind of fall back, I think, to generics or something. Okay, so that's affecting the entire page. It looks like we've got some pretty heavy latency, and we're not getting anything back. I'm going to hold that attack. And obviously this would be not something I'd want to do in production immediately. That would not be the idea. Kind of just testing to see what things are coupled together, and I'd want to do this in a safe and controlled environment. So that was a bit of a learning there. So we know now that something that probably shouldn't be in the critical path for checking out and buying products from our company is something that is actually specifically essentially a blocker. And that would be a learning that we take away, and something that we want to think about and remediate in the future. Cool. So looking at the microservices that we've got set up in our mental model of how this all worked, it kind of comes up that, we need to think about uncoupling things that really shouldn't be in that critical path, and kind of dealing with those things, and doing so, in a way that's collaborative as well. This is why it's really important to have a broad swath of people in the room from different interest groups, because obviously, if this is something that SREs are doing alone, that's not going to be as viscerally communicated to people working in the applications as it probably should be. So that's worth keeping in mind. This is obviously something we want to stay as collaborative and transparent as possible. So I just wanted to add another, in closing, I guess, another great Ian Malcolm quote. I use this meme all the time. The scientists were so preoccupied with whether or not they didn't stop to think of if they should. I added this in because I was like, don't be this person. Um, and I think that's probably something you should take into life. Like, just don't be this person in life. But also think about um, how chaos engineering can practically help you. Like, if you're at a company, um, what you want to do at your company is really think about what are the practical business concerns that you have, what are the vulnerabilities that um, your complex system faces. Asking that question um, of what will happen if, um, and doing so in a way that's really pragmatic. As I said previously, this isn't really about just like breaking stuff, um, and and it's pretty important to think about doing this in a way that is inclusive, collaborative, and really transparent as well. I wanted to just like add a couple of plugs to useful stuff. Um, Obviously, these look like they both go to the gremlin.com website, but the Slack one's just a redirect. It goes to um, a chaos engineering community. It's got like I think 6,000 or 5,000 plus people on it now, and lots of different people from all over the world, kind of dealing with their own chaos engineering concerns. They've got their own different questions, different problem sets they're trying to deal with, and they're all using different tools and going about things, um, coming up with different solutions as well. Um, so it's a good community to really be a part of and collaborate within. And you can obviously that might be an environment to share your learnings as well if you come up with if you have some interesting insights from your own experiences. And the gremlin.com/community page is a pretty good resource for getting kicked off. Um, there's another one I should have added in, but uh, I missed it. There's a GitHub repo by the handle's Dastagon, and it's awesome chaos engineering. It's like a super good resource for all things chaos engineering. If you just want to get started and you don't know where to start, it'll it'll give you a lot of guidance to like a whole bunch of different stuff that's all chaos engineering related. And yeah, that's it for today. Thanks for having me. This is a really cool event. Um, and I can't believe it's been going for like 23 hours. This is incredible. But yeah, awesome to be here.
Thanks. Thanks, Patrick. So you have 2 minutes for the Q&A, so that's quite short. There are two questions, Patrick. So in order to respect the agenda, because we have a hard stop, we need to quit the office before the alarm starts in the office.
Oh yeah, no worries.
and then I have a taxi driver that will bring me back home.
Good luck.
So what I would suggest is, Patrick, there's two questions from the audience. If you look at the Q&A, there's a Q&A. Yeah, if you can answer them directly, I will take advantage of this 1 minute left to introduce the next speaker, so we can respect the current the initial agenda.
Yeah, okay, so number one, any suggestions for alternative tools to Gremlin? Something behind the firewall that we can host. There is a lot of there's a big community around Russ Miles, and I'm sorry, I'm forgetting the other couple of fellas' names. But essentially like a European-based open source first chaos engineering collaboration. And it may be worth checking that out. I would suggest going to that awesome chaos engineering GitHub repo and checking that out. That'd be like a super useful way to start. And the second one, how mature is chaos engineering? Seems to me it's not commonly considered in most organizations who barely have time to deliver functionally working software.
I think it really depends. I
Oh,
think it
go
depends
ahead.
on. Yeah, I think it really depends on the maturity. And what we when we questions, because we did a survey, there was based on 500 customers that we questions, there was like 5% that was sort of considering the activity. I think people was not even aware properly of that the job or the task behind that. I think
Yeah,
either it's pretty mature company that start investing, but I think there is a lot of value behind that. So I think it's
yeah,
just
totally. I think an outlook is really worth examining there too. Like, if you always take the approach that you're just delivering and just trying to ship code, like that's kind of a problem. Um, and and I think asking the questions about how to produce better experiences for your customers, whether it be through performance engineering or chaos engineering, is like always a good question to be asking. Um, so I don't think it's really about maturity; it's just about outlook.
yeah. But I think yeah, it's gonna. I'm pretty sure that the next 12 months or maybe more, I don't know. But I expect that more companies going to invest more and more in those in that activity because it brings basically a lot of values. I mean, Mark, we used to do failover testing to do where we were manually turning off systems a few years back, and now we just basically we have the ability to automate that. So it's always better to automate than and make a phone call say, hey, could you turn out that one?